Welcome to Regression Tutorial 4. In this tutorial we will test the model that we previously developed. In particular, the two models for the estimation of the wine prices we will now test with the test data that we set aside. Recall the regression output from our first model. Here we have the independent variables points, age of vineyard, recent vineyard awards, and Burgundy. The coefficients for the intercept is 16.346, for the points 0.725, for the age of vineyard 0.036, recent vineyards award 0.694, and for Burgundy 1.387. The regression equation, therefore, for this model looks like this. That is, given the data in the test data for x1, x2, x3 and x4, we can calculate our predicted price for the bottles in the test data. To do this, we copy the data from our regression output and paste it in a special way into our test data sheet. In particular, we transpose it so that the data is in the same alignment as our test data. After some cleanup and some additional work, this looks simply like this. I entered here the actual prices of our test bottles, and now I would like to add next to it the predicted prices for the test bottles using our regression equation. Well, this would be equal to 1635, our intercept. Let's make sure we use an absolute cell reference, plus, and now I would have to do something very tedious. Basically, I would have to multiply K 108 times C 109 plus L 108 times D 109 plus M 108 times E 109 plus N 108 times F 109. Well, this of course is very tedious, and fortunately Excel has a nice shortcut for us. This is the sum product command, which simply works by adding arrays that you want to multiply with each other in this fashion. So basically the first array is the array of the coefficients of our variables. And let's make sure we press function F4 to make these absolute. And the second array is simply the variable values from our test data. Let's close the parentheses and hit enter. Now we simply can drag this down, and it will complete this for the entire column. Now, the predicted prices look very close to the actual prices, which is a good sign. However, there are better ways in determining how closely they are related. The first one is simply to figure out the correlation between the actual price and the predicted prices. This we can type here equals correl of the first array, the actual prices, with the second array, the predicted prices. That is a wonderful correlation, very high, so this means we have a fantastic regression. The second way of doing this is a visual approach, namely to simply print the scatter plot of the data. Let's select the data, let's go to Insert, and then take Scatter Plot. Select the scatter graph without lines, and here we have the scatter plot between the actual price and the predicted price, which, after some cleanup, looks something like this. Just as the correlation indicated, the graph also shows that the predicted prices are very much in line with the actual prices. So, in other words, we have a great regression here. Next, I would do the same thing for the second regression model, the one where we used, instead of the age of the vineyard, the logarithm of the age of the vineyard. For the regression with the logarithm of the vineyard age, we had this summary output, and transferring our values for the coefficients to our test data yields these data, and in complete analogy as to before, we compute the predicted price for a bottle of wine by adding up the intercept, absolute, plus the sum product of the coefficient in absolute references and the variables in relative cell references. And dragging this down yields these predicted prices. Once again, the prices look closely aligned to the actual prices. Once again, we compute the correlation between the two data sets, between the actual prices and the predicted prices, and have an unbelievably high correlation of 0.989. In our visual description of the relation between predicted price and actual price, again we find a line closely aligned. The predicted price follows the actual price very closely, high correlation. So now we have basically two different regressions, each of which is fine. The regression based on the logarithm of the vineyard age is slightly better theoretical. It performs slightly better. However, it has one downside. The downside is of a practical nature. The coefficient for the vineyard age is $3.18. But $3.18 for what? $3.18 per logarithmic year. This is very hard to explain. On the other hand, in the original regression, the coefficient for the age of vineyard was 0.036. That is 4 cents for each additional year of vineyard age. This is much easier to explain. So in the end, it boils down to two choices. One, a slightly more sound mathematical model. The other one, a slightly more intuitive model. Which one you choose in the end will depend on your own preference. In either event, you have a great model, a model that has been tested on out-of-sample data, a model that has a reasonably high R-square, a model that has reasonably good p-values, at least for the first three independent variables, and a model that has a so-so p-value for one of the dummy variables, the variable for Burgundy.